Good morning and welcome to the first of our online workshops for E-Plex, presented by E-Plex Head of Sales, Julian Potter. Good morning, Julian.
Morning, Mel.
This morning's session covers initial system design and what to consider when you're looking to install a system. We hope it will be useful both for E-Plex dealers looking for a refresher and customers looking for a new system. If you would like to ask any questions, please submit them in the Q&A panel. We'll aim to answer them at the end of the session. Okay, over to you, Julian.
Thanks, Mel, and thanks to everyone for tuning in. Thanks to those who have got up a little earlier. We seem to be all over the world at the moment. So for those of you who got up a little bit earlier to join us, thank you. And for those that have stayed up a little bit later, much appreciated. So today we're basically going to go over the initial system design and system thought processes. So not heavily talking about programming or how the E-Plex system works, just about some of those considerations that we need to take into account when we're starting to go from a hardwired system into a digital switching system. So for those of you who are online at the moment that are familiar with that kind of thing, this may be a little bit something that you're way too familiar with, but I just thought it would be a good place to start for some of you who have tuned in who are not familiar with going from a hardwired system over to a digital switching system. So, size of system, what are we going to do? What is it that we're looking to do? So we're changing from hardwire over to digital switching. And you've got to then start to think about the size of system that you want to implement for the first time. Is it a first system? Is it something that you're putting your toes into for the first time? Are you going to do monitoring? Are you going to do control? Or are you going to do a little bit of both? Obviously, this just adds to whatever complexity that you're going to put down onto the system, and then obviously into the build. Is it a second generation system? So have you already gone through the process of your first, basic system, and now you're adding to it, putting in some more control, putting in a little bit more monitoring, maybe looking at some automation or some large scale automation where you're now starting to put lots of different circuits together, switching on together, switching off together, some circuits switching on based on maybe some inputs from battery monitors or from tank monitors, etc. So any automation. And then remote access. That's also a thought process that you might want to kind of think about later on down the line. It does add a reasonable amount of complication into the system as to how you're going to do it, where you're going to do it, who's going to get access. So just think about that initial size of system that you're going to do before you start laying out any information. Also, what's really important to stay in touch with is why it is that you're actually doing this. So what is your drive between going from a hardwired system over to a digital switching system? Is it just for kind of increased customer functionality or features, something that you want to give a little bit more, feedback, control, some goodies, some toys over to the customer? Is it just that you want to get some sleeker aesthetics rather than a conventional AC/DC panel? Are you looking to go more touchscreen with some nicer graphics, maybe being able to use, an iPad or that kind of device remotely around the boat as you walk around? Is it improved production times? Is it that you're looking to get a handle on maybe increasing efficiencies in the actual production line itself, making sure that two kind of electrical engineers, obviously this is obviously based on an electrical system, but making sure those electrical engineers are doing the same thing every time? When what I've found in the previous experience with production boat builders is that obviously you have a number of electricians going around, and one may have a slightly different way of doing things, which can cause complications and confusion at the end of the line when if there's a fault and if there's fault finding to be done. So what multiplexing generally does is it does streamline that kind of process, and also brings everything very similar, so that it's more repeatable every time. As I said, reduce end-of-line faults. One of the things I did find, again, in previous life within production boat building, is that from a hardwired system to a multiplexing system, the end-of-line fault tests on that part of the boat did decrease quite considerably when going to multiplex. Basically, just because there's a lot less points of failure with regard to putting the wires into switches, into control panels, less wiring going around the boat. So it did actually help the end-of-line faults. And this is one thing that's, we're all looking for efficiency. We're all looking to be a bit greener, better running. So these are all things you can take into consideration when moving into a digital switching system. So how do you start? Well, first of all, obviously, it's very simple. Let's take lighting controls, for example. How many lighting circuits have you got in the boat? So you might have, 3 cabins, a saloon area, galley area, outside cockpit area. So you split that into those different areas, look at how many particular circuits that are in that area, and then divide that over, a particular module or whatever as to how we're going to get that moving forward. Create a spreadsheet and just obviously put all the circuits in, put your current load calculations in there, have a look at what each circuit draws from a current perspective, and then you can see whether you're going to be overloading that circuit, whether you need to split it out onto another circuit. Once you've done, obviously, lighting control, which is a great place to start, ancillary controls like fans, pumps, look at those, look at the manufacturer's fuse ratings to help you decide as to which module type they're going to use, and how you're going to configure the circuit breaker within that module to be able to obviously control and protect the wire that's feeding that device. Check all your load calculations, make sure that you are in the recommended range for each particular module, and then start to lay those out around the boat. Module locations obviously is very important for a number of different reasons. First of all, try and locate the modules near the respective loads to reduce the wire runs. This is obviously one of the aspects of digital switching, which is very important. What we're trying to do is obviously make things less complicated. We're trying to remove wire out of the boat as well. And one of the things that people do miss is, if you can imagine a circuit breaker panel, then a switch, then the load, and you've got all those wires going in between from your battery. It's a much longer run, obviously. With your volt drop calculations, you might need to increase the cross-sectional area of the wire because of the distance that the cables are actually running. Now, obviously, when you move the modules as close to the devices as possible, that wiring length is much, much less. And one of the things that people do have a tendency to miss is to revisit that cross-sectional area of cable size. So again, you can check the load that's going to be on the end of that cable, check the current draw, check the voltage drop calculation, which should be much, much less because of obviously the length. And then at that point, you should be able to change the cross-sectional area of the cable, which over a number of circuits on the boat will actually start to add up to a reasonable amount of weight that's reduced. When you're placing the modules, just ensure accessibility for manual override use or maintenance. So on our power distribution module, which I'm showing there, the 805, you can see that we've got the manual override controls here. So this is if you do lose network connection for some reason, you can still power the devices and the circuit breakers within the device still operate. So being able to get to those modules in a situation where you might need to take over with manual control is obviously very important. Think about using inputs and outputs together on those modules as well. So obviously the modules can take information into them with regard to kind of close contact switches, etc. So if you've got a module, for example, down in the engine bay, which is controlling engine fans, bilge pumps, engine room lights, that kind of thing, it might be that you want to take some alarm sensing information from the engine hatch up to the helm or up to the main display. So again, if you've got a spare channel on that module, think about how you can utilize those channels to give you more information back. So you can wire the micro switch from the engine hatch up to the spare channel on there, and then just send that open or closed information up to the main screen. So just try and, you want to keep some spare channels maybe for future future kind of modifications, but if you've got the spare channels to utilize them in that area, you know, try to do so as much as possible. So once you've actually decided what you're going to be controlling, where you're going to be placing those modules, you then need to start thinking about how to kind of put that system together. And before we kind of get into the programming side of things, which obviously we're not going to talk about the detail of the programming here, but the first things we're going to need is the 400 ECM or 450 ECM, which is the clock module, the main processor for the system. So it does store the system design on the clock. So this is obviously, it's required for every design that you need. And it stores the design and stores the module commands. So as I showed in a previous webinar, if you press a button on a light switch, for example, that signal gets sent to the clock then knows which module it needs to go and switch on, and that's how it runs through, and that's what it does. So the good thing about the clock is it does actually double as a touch screen and a basic display. So if it is a basic system, if it is your first system and you don't want to go heavily into doing graphical displays, you can actually use this as a monitoring interface and also a control interface. So you've got a small screen here which is completely customizable as to what you want to see. So here we've got kind of battery voltage, you can have water tanks, waste tanks, current, whatever you need to see up on here. It is very basic, but it does give you an insight. This panel here is a customizable graphic, it's an insert, an inlay. You can come up with your own design here, and all of the regions can be programmed so that they switch devices on and off, or they just change page on here as well, so that you can scroll through to see the different pages depending on what you're monitoring and controlling. So you're going to need one of these. This is kind of the main processor for the system, the main brain. And it is a good way to grow slowly with adding monitoring at a later date. And if you wanted to then change into a different display, this is always a good backup to have on a larger boat, down in a crew cabin, something like that. And then your main display can be, you know, a PC-based, you know, graphical display, something like that. So once we've got our clock put into our design, we're then going to use our power distribution module. As I said before, this is our 805 output module. It's a digital controllable fuse box, for want of a better description. So basically just look at this as a mini 8-way fuse box. But rather than having the kind of conventional fuses or circuit breakers, these are driven by MOSFETs, and they're controllable, programmable circuit breakers. So each of the 8 channels can be programmed anywhere between 0 to 15 amps. Once that's programmed, as I say, 8 channels up to 15 amps. It's got light dimming capabilities as well, so great for obviously mixing between, you know, internal light controls, plus also there might be other fans or pumps in that area that you might want to control as well. Just your networking information comes in here, and then your power supply goes up onto the 2 studs up here, so your positive and negative both return from the load and to the inputs as well. As I said before, from an input perspective, if you look on this diagram, we're obviously controlling some LED lighting, some halogen lighting, motor loads, etc., powering up the nav equipment. But also we've got some conventional closed switches which are coming into this module as well. Okay, so what that's, as I said before, allowing you to do is being able to, it might be there's an area that you don't want to use a touchscreen light switch, so you just want to use a conventional light switch just for cost, maybe out in the cockpit area or into the heads or something like that. Or it might be that you want to use a micro switch for whether engine hatch is open or port lights or something like that, to get an alarm before you go underway. So all of that kind of thing can be fed back into the module as well. Pulling it all together, those inputs don't have to control the outputs of that module. They can control the outputs of another module somewhere else on the vessel. So always bear that in mind. You can try and get as much out of the system as you possibly can. So control interfaces and locations. So looking at the 416 TPS, for example, so this is our digital light switch. Again, it's good to remember that you can use light switches like this to be able to control multiple areas. So even though they may be a little more expensive than a conventional light switch, there's obviously only 2 wires going to the back. So your networking cable comes to the back of here. Your inlay is completely customizable. And then basically what you can do is control the lights in an area. So in the bedroom, for example, so being able to control the main lights, the lights over kind of the reading lights example, but you might also want to be able to control toilet lights, in the middle of the night, or be able to just switch all the lights off on the rest of the boat. So being able to have that kind of multiple area control makes it much more powerful to be able to use this kind of thing on the digital switching systems. Okay. This one, for example, as you can see, has actually got 9 functions on here. There's 10 programmable areas on that screen. So again, being able to kind of move those around, think about how your devices are going to be set, how they're going to be controlled, which areas you want controlled by what. So all of these things you start to plan as you move forward. And the good thing is that because there's only 2 wires, it's a network connection going to it. If you do decide that it's not perhaps in the right place and you want to move it, it's actually not a big job. So from a basic system perspective, if you've gone, let's look at just a conventional lighting system, for example. So if you have gone down the route of just a lighting system, you've put your clock into place, maybe as just a display and some overall control in the saloon area. You've obviously got your modules based around the boat, close to the loads, reducing that wire size and controlling all of the lights in those different areas. Just because they can do an on and an off function or a dim up and a dim down, don't forget to kind of add a little bit of functionality if you can, a little bit of extra bonus toys, just because you can. And again, it gives the customer something to be able to enjoy and get benefit from on the boat. I've shown this slide before in one of the previous webinars, and one of the favourites is an all lights off situation. So obviously you can control your main lights from one module. Your spotlights may be attached to another module and maybe on the same. And then obviously helmet lights again. So you've got all of these different areas that are being switched and controlled from one light switch. And then when you go off the boat, you might just want to click that all lights off button and everything is off. So it's a nice bit of added functionality that you can add for free because it's just software programming. And most of that programming is already kind of available and done, so it's very easy to put that in. Don't forget that button can also coexist on the panel, so it might be that you've got that light switch unit in the bedroom area or in the saloon area, but as you're going out of the boat on the panel, or even wired directly to a conventional switch in the cockpit using one of the inputs, just a momentary switch, it can send that signal and turn off all the lights on the boat. So again, by adding that functionality, gives you an extra bonus. It depends as to what you're using the multiplexing for. Even if it is just a streamlined production, you can still add functionality, even with conventional switches, just to give a little bit more back to the customer. So it's also important to select the appropriate interface for the area that is where that interface is being used. So again, internal cabin space is great for touchscreens and that kind of thing when boats generally at rest, or you're not concentrating on other things. Up at the helm, it's very important to be able to use something that that you can hit first time. Certainly from a horn perspective in an emergency or anything like that, but something that you don't want to have to go scrolling through pages on a touch screen to be able to get commands up and running. So a conventional rocker switch panel is a great way to still remain into that very familiar control scenario up at the helm. Now this is our digital version, so it looks very similar to a standard conventional rocker switch panel, but there is only 2 wires on the back of this function, on the back of this switch. All of the LEDs are all programmable and controllable as well. So again, suitable for helm use. You get the full feedback from the LEDs up here as to what's actually going on with the load. So engine fans, for example, this light can be green when they're running, but if they do trip and the system can see that there's no current being drawn, this LED can change to a flashing red, etc. So you're actually getting correct, proper feedback from the system, not just, you know, a made-up alarm or anything like that. It's a true live feedback as to what's going on. Very important to be able to use, not just on the 428 RSP, but making sure that where you are, depending on what area you are using, you're using the right interface, and think of it from the customer's perspective. It's very easy as an engineer to sit back in the design office and put things together, and sometimes lose sight a little bit of the environment that we're going into. So it's very important to make sure that we correctly use the right interface. So what would a basic system cost? And we've kind of just thrown this together just to give you a bit of an idea as to where you're heading. So this is a very basic system with a clock, 2 power distribution modules, 428 RSP, which is actually a 5-way, just a picture of a 4-way there, a couple of TPSs for lighting control, and then also your 331 BMI, which is just a battery monitor device. So a system like that is going to cost somewhere in the region of £3,200. That's including all of your T pieces and your wiring links as well. There's obviously potentially some programming that might need to go ahead with that, but depending on how basic that is. You can see here listed the devices that you put in. You've got your 400 ECM, your 805 octal power modules, your 416 TPS, BMI, rocker switch, and then you've got your cables and T connectors. So that's a basic system kind of all thrown together that would actually get you quite a long way into getting into digital switching for a first hit. Now, once you've done that first system and that's all running along fine, what you might want to do then is start thinking about in the future how you're going to increase some functionality. You haven't got to do a massive redesign of the system. You can just start to add modules, tweak the version of the design by adding the modules into the design. We've got a couple of different tank monitoring modules, obviously, for pressure and being able to use standard resistive sensors. They can get wired directly into here, and that information can then be moved up onto the 400 ECM to display that information, or you could add, you know, a 900 HMI if you wanted to go more into the graphical side of things. Again, as I showed in that basic system, we had a BMI to show the battery monitoring capabilities. That information would be up there. You might then want to start looking at perhaps putting an AC monitor on. That might just be for a shore power connection. It might be that you're starting to supply a generator and you want to show that information up on the system as well, or at least utilize some of that information to do some controls. Again, expanding further, normally onto the larger vessels, we start getting into controlling the AC power. We've got, you know, a range of 8 and 16 channel options for that, selectable circuit breaker configurations, so that you can, you know, start to control and monitor your AC power. So you can do some intelligent load shedding as well. So that means you're not doing nuisance tripping on your breaker on the shore power, and you can just control. You take more control over your AC systems. So that's basically been just an overview of what to start thinking about when you start considering going from hardwire over to an E-Plex digital switching system. As I say, brief overview. Not heavily going into the design side of things with the software. There's going to be more and more of these webinars as we go forward, and we continue in this situation of not being able to do too many in the way of visits at the moment. But we're going to continue to load these through. If there is any particular side of the E-Plex that you'd like to see on one of the webinars, feel free to send me an email. And we can put a specific webinar together, because, you know, if it's something that you're interested in, there's a good chance that there's plenty of other people that have the same question as well. So feel free to put that together and send it across, and we can do that. The next webinar from the marine perspective, going into the design side, we'll start to look a little bit more as to how we would then start to put going from a basic system putting that design together in the software, so I can show you some of the software options that we do, how to get the graphics interfaced into that, and then also start to think about what we would look to on the next stage of the design. So thanks very much for watching. I hope that's been of interest, and any questions, let me know.
Thank you, Julian.